Okay, back with standard deviation or variation in standard deviation part 2. Need to talk about sampling from a population, and this is really just a notation thing. Again, a lot of words, a lot of talk, but it's very important that you understand the different symbols. I think you can understand the difference between a sample, a random sample, and a population. Quick example. Let's say we wanted to know, I don't know, we're taking a survey about the something silly, like the favorite color or the favorite colors of students at Windermere Prep. Well, right now I think we're at about 1,200 students, right? So if I have a population of 1,200 students, even though that's not really a very big number, I don't think that you would want to try and track down all 1,200 students and ask them what their favorite color is. So to get an idea or a good estimate of what everybody's favorite color is, maybe you take a random sample of, I don't know, a block of 100 students. And that is what you base your survey on, or what the results of the survey. You base it on a sample. Okay, so we have a sample and we have a population. The mean of a sample is, we're already used to this, is represented by X bar. For the entire population, if we were able to survey the entire population, and now this wasn't a numerical example, color wasn't, but maybe it's like the average heights of all the students at Windermere Prep or something like that. If it's numerical, then the population mean is the lowercase letter mu, Greek letter mu. I think it's spelled mu. Yeah, and that's the lowercase letter mu. Variance, we already saw that in the previous example, S sub n squared. And that's for if it's a sample, and if it's a population, it's the lowercase Greek letter s, which is sigma squared. Standard deviation, the square root of variance, s sub n, and the Greek lowercase letter sigma for the entire population. So it's just really a matter of notation as to whether we're talking about a sample or a population. Without proof, what we shall accept is the mean of the sample, X bar, is an unbiased estimate of the mean of the entire population, mu. So we can use the sample mean to estimate the actual mean. We can use the sample standard deviation to estimate the actual standard deviation. So it's just a matter of notation. Okay. So let's go back to the end of our first video where we found these standard deviations here of our sets of data, 2.61 and 1.41. And I want to show you how this looks on the calculator. So first, let's remember this 2.61 for our survey 1 data. Okay, and we'll go to our calculator here, and I already have the data entered in. Actually, I want to go here. Okay, 376,811, and I'm going to get my one variable statistics here. Let's see, 4 for statistics, stat calculations, 1 variable stats. I just have one list. Okay, I want, let's see, survey 1. Okay, and there we go. Okay, so if you look down here, we have our sample standard deviation and our population standard deviations. So let's go back real quick. Okay, and here it's 2.61. And oops, I don't want to go there yet. It's 2.61. So I go back to my calculator, and 2.61 is the population. And you might think, well, wait a second, Mr. B, that was a survey. Well, the calculator doesn't know whether you have a survey or the entire population. So it always assumes that you have the entire population. That's all it knows. It can't think. So as far as it's concerned, these 5 pieces of data is the population. So this is what we are always going to use for standard deviation. This is for something else, and it's beyond the scope of this course. So we always use the population, the sigma, for our standard deviation. And you can see the 3 significant figures. That's 2.61. Now I'm going to do the same thing for survey 2 just to drive the point home. Menu, statistics, stat calculations, 1 variable stats. Okay, I want it to be survey 2 this time. Okay, and everything should be great. And we're just going to look down, and you can see 1.41 is the standard deviation, the population. And again, the calculator is saying, okay, that's the population. You gave me everything, so I'm considering it the population. And the standard deviation is 1.41, which is what we have here. So don't let the notation get you confused. I guess the upshot is on the calculator, for standard deviation, we are always going to get or use the population. How could I get the variance from this? Mr. Becker, where's the variance? Well, they don't list the variance because all I would have to do is square this. Remember? The standard deviation is equal to the square root of the variance, which means the variance is equal to the standard deviation squared. We really don't have to do that all that much. Okay, all right, now that that's over with, let's take a look at this example right here. A random sample of 48 sheep was taken from a flock of over 2,000 sheep. Okay, so again, so you have to read. This is the reason why it's very important that you have an understanding of what all these symbols mean. A random sample of 48 sheep was taken from a flock of over 2,000 sheep. The sample mean of their weights was 48.6 kilograms. So the sample mean, that's this symbol, is 48.6 kilograms. And the sample variance, which is S of n squared, is equal to 17.5 kilograms squared. Okay? Find the standard deviation of the sample. Hence, estimate the standard deviation of the population from which the sample was taken. Okay, so to find standard deviation, that's the square root of the variance. So S sub n is equal to the square root of 17.5, which I will tell you is approximately equal to 4.18. Okay, and it says, hence, estimate the standard deviation of the population. Well, by definition, S sub n is an estimate of the standard deviation sigma. So we are allowed to say, oops, that's a horrible sigma. There's a sigma, is approximately equal to 4.18 because we have accepted without proof, that's beyond the scope of this course, that the sample standard deviation is an unbiased estimate of the actual standard deviation of the population. Okay? Find an unbiased sample of the mean weight of the sheep in the flock. Same thing. The mean of the sample, x bar, is an unbiased estimate of mu, the actual mean of the population. So we can say mu is about equal to 48.6. Okay, one last example. Standard deviation for group data is given by this nasty formula, which is the same formula that is right here on your formula sheet. Okay, what does all this mean? Okay, that's group data. That's like a frequency table. Here's an example of group data. I don't know, let's say there's some sort of game where you can either score a 1, a 2, a 3, a 4, or a 5. And the frequency of a score of 1, that happened 1 time. A score of 2 happened twice. A score of 3 happened 4 times. A score of 4 happened twice. A score of 5 happened once. So to calculate the standard deviation, I have to multiply each individual piece of data by the number of times that it happens. That's what f sub I is. So if, let's say, I don't know, let's talk about this piece of data right here. And let's say if it was f sub 3. So f sub 3 of x sub 3 minus x minus the mean squared. So I would take 3 minus whatever the mean of the data is, square it, and then I would have to multiply it by 4 since it happened 4 times. And we divide it by the sum of the frequencies. Okay? That's all very, I think that's all very jumbled and confusing. The good news is most of this work you will be doing on your calculator. Okay, so to these formulas, again, these are the same formulas. This mean formula is the same as this mean formula. This variance formula is the same as this variance formula. And this standard deviation formula is the same as this standard deviation formula. The only difference is the symbols to show you the difference between a sample and a population. What are the differences? Very simple. Only the mean, here the mean is represented by mu, and here it's represented by x bar. And then the variance and standard deviation for the population are represented by a sigma or sigma squared. And here it's S sub n or S sub n squared. Exact same formulas. Okay. Okay. So find the standard deviation of this distribution. Let's just, it's easier to show you real quick. And again, you would most likely, if you had to do it by hand, it would be very, very, very simple. This would be the outermost stretch of having to do it by hand. Okay. Find the standard deviation of the distribution. Okay, here are the scores. 1, 2, 3, 4, and 5. Here's the frequency. 1, 2, 4, 2, and 1. Straight from here. Here's the frequency multiplied by the score. 1 times 1 is 1. 2 times 2 is 4. 4 times 3 is 12. Okay? And so on down the line. Then they took each individual piece of data and subtracted the mean. Now the mean has been calculated for us. You would know how to calculate the mean here. It is equal to 3. So I take 1 minus the mean. I'll put a 3 right here. 1 minus 3 is negative 2. 2 minus 3 is negative 1. Go down here. 5 minus 3 is 2. Remember, then I have to square it. Negative 2 squared is 4. That's this part of the formula right here. Negative 1 squared is 1, and on down the line. And then I have to multiply it by its corresponding frequency. That's this f sub I thing here. Okay? So for the data 1, it occurred 1 time. 4 times 1 is 4, right? The data piece 2, it occurred twice. 1 times 2 is 2. Okay? The data piece 3, it occurred 4 times. Well, this turned out to be 0, so it really doesn't matter. 0 times 4 is 0. The data piece 4 occurred twice, so I multiply that by the frequency. I get 2. I think you get the idea. This would be times 1. That gives me the 4. And this is the sum of all of these. I divide, and that turns out to be 12. 4, 2, 2, and 4 is 12. I divide that by the sum of the frequencies. 1 plus 2 plus 4 plus 2 plus 1. Again, that's just finding the average. The number, that's the number of data here. That's the total number of data. That's really like your n before. Take the square root of it, and I get my standard deviation. On the calculator, that is very simple. We looked at that before. I entered the data in for us before. Okay, the score and the frequency. I'm going to go to Menu, Stats, Stat Calculations, One Variable Statistics. It is one list. I want to do, let's see, the score. And then I need a frequency list. Okay, remember, frequency I labeled as freak. Everything's okay. Get my one variable statistics, and there it is again. That rounds to 3 significant figures to 1.10. All right, that's it. One more video on this, and we are done.